This work presents control of two-link manipulator with reduced online computation. This study is about the reduced online computation approach, and it will be simulated using MATLAB software. In order to evaluate this technique, is expected to use two controller algorithms: desired compensation adaptive load controller, adaptive inertia related controller. Desired compensation adaptive load controller only uses the desired trajectory information which provide the position, velocity, and acceleration. The regression matrix is calculated in offline fashion. On the other hand, adaptive inertia related controller uses the desired trajectory information in addition to the current trajectory information from the manipulator. Therefore, the regression matrix is calculated in online condition. The following diagram blocks illustrate the desired compensation adaptive load controller and the adaptive inertia related controller. Notice how the information from the desired and current trajectory interact with the regression matrix of the adaptive inertia related controller. However, in the case of the desired adaptive load controller, only the desired trajectory information is required. In this part is presented the performance of these controllers after simulation of sinusoidal trajectory. The first set of images illustrate the performance of the desired compensation adaptive load controller. It can be seen on the left the sinusoidal inputs for Q, Q dot, and Q dot dot, which represent position, velocity, and acceleration of the desired trajectory. The performance from the controller is seen at the central images. These figures show a transient at the beginning of the simulation. The signal went up and down for about 2 seconds. After that, the controller is capable to track the trajectory. The error between the desired and current position of the joint angles are presented in the right figures. The following pictures show the performance of this adaptive inertia related controller, processing the input signals. In view of these figures, the controller performance is reliable in following the desired trajectory. According to these images, the controller is capable of pursuing the desired trajectory rapidly from the beginning of this task of simulation. It is also shows a higher stability and no fluctuation period at the beginning. In this part is presented the performance of these controllers after simulate a rectangular trajectory. Desired compensation adaptive load controller following a rectangular trajectory. The following According to these images, the controller is capable of following the rectangular trajectory from the beginning of the simulation, showing higher performance. The controller reduces the initial error rapidly at the beginning of the simulation time, and then follows the desired trajectory efficiently as the figures show. Consequently, the error between joint angles desired and current is almost zero at the beginning of this task simulation. The controller is able to follow the trajectory with high accuracy as is shown in the figure. The controller is capable of tracking the trajectory from the beginning to the end of the simulation time. The error is, in this case, starts at 0 and is around to the origin during the total simulation task. This fact is supported with these images. The desired compensation adaptive load controller shows fluctuation at the beginning of the simulation, but higher performance when the initial error is 0. Thank you for your attention.